Starting with the very basic concept of pointers, we already know that if we want to access the address of any given variable, then we will require a pointer to store that address of the variable by simply saying int a. We have a variable, and if we declare a pointer of the same type, then p is eligible to store the address of a, right? So whenever if we try to display p, we are going to observe that some address is going to be printed. Fine. Now that address definitely will be the stack address. Now, moving ahead, if we say that we want to access the value of a through the pointer p, then we know we have to show something like this. So instead of p, if p is going to give me the address of a, definitely it's going to give me the address of a because it stores the address. But if I want to access the value of a, so I'll have to go at that address and then access the contents at that address. That is address of a. So that is why I mention a star p. So p represents the address and star represents the contents present at that address. Fine. Okay, so this is a pointers in a simple way. If we want to describe pointers, it's a indirect access to the value, right? We are usually accessing the value with the name given to that value, whatever variable names we use for those values. But when we say we are using pointers, we are indirectly trying to access the value through, not through the name, but through the address of that value we are trying to access it. Okay, so this is a basic concept of carries the address of another variable. So as I told, with the value we are accessing directly, with the address we are accessing indirectly. Fine. So general syntax for having any pointer is the data type, obviously. Then the pointer name preceded by a asterisk sign. And different types of pointers we can have: an integer pointer, float pointer, double pointer, character pointer, n number of pointers. How do we initialize the pointer of any variable is we have to pick a value from the valid set of values. So if we say integers, we have a defined range for integers from where we have to pick one value and assign it to a integer variable. Similarly, if we have to initialize a pointer, we know pointer should be initialized with address of a variable to which the pointer wants to point. Right? So we use the address operator we just now saw. Ampersand is called as the address operator in order to find or in order to determine the address of any given variable. And preceding any variable name, if we use this ampersand operator, then it refers to the or it returns us the address of that given variable, right? Like we say ampersand a, so it gives me address of a. We all know it. Yeah, simple. A pointer is declared and the pointer is initialized. Now, pointers and arrays, these are used in combination and perhaps very interesting concept in when we refer to the pointers topic. So pointers usually we use to store a single address, right? So pointers can not only store the address of a single variable, but now we can use a single pointer to store address of different cells or elements of an array, right? So just see this example. We have a pointer ptr and we have an array of 5 elements, right? Now when I say ptr is equal to arr, that means somewhere the array was created of 5 elements and arr itself is the name of the array. Now we are creating a pointer ptr which is pointing to the same memory location, whatever the memory location is at which arr is pointing. That means it's pointing to the 0th index. Fine. Here the explanation itself says that when we perform ptr is equal to arr, it will store the address of 0th element of the array in the pointer variable ptr. So if that is so, when we say ptr is equal to address of arr of 0, what we are saying, ptr should carry address of 0th element. So if we say address of arr of 0, these two values should be the same, right? So the same thing is given over here. So if we try to access, if we try to assign ptr with the address of 0th element of the array, then also we are going to get the same result in ptr. So addresses for the rest of array elements, we can access them simply by mentioning the index, changing the index. Address of the 0th element we got in this way. Address of the first element we can get in this way. Address of the second element we can get in this way, so on and so forth. Any doubt? Because what is present at this 0th index, an integer value is present whose address we want to assign to ptr. Whereas here arr is as good as a pointer. We saw arr itself is a pointer. And if we say ptr is equal to arr, then ptr is also pointing to the same memory location. Got it? That is why pointer being assigned to a pointer will be not using the ampersand. Right? If I create another pointer qtr and I say qtr is equal to ptr, then qtr is another pointer which is pointing to the same memory location. Right? That way it is. Now what happens is if we say ptr is pointing to the 0th index, if we start incrementing ptr by 1, obviously it will go ahead by how many bytes? Since it is an integer pointer, it will go ahead by 4 bytes. Right? So when we say ptr plus plus, instead of pointing here, it will point at the next 4 bytes of block. And then we will be able to access. Now if we say after incrementing, if we try to display the contents present at ptr, we'll get the contents of first element. Fine. Suppose we need to point at the third element. So what we can do is we can simply add ptr with 3 so that it now points at the third element. Just now we discussed by ptr plus plus, we are making the pointer point at the next block. but we can simply go ahead by as many blocks as we want by mentioning the count over here, right? So PTR will jump by 3 integer blocks, and then whatever memory location it is pointing to, the contents of that memory location we can access. Same thing is given over here. PTR plus 1 is equivalent to ampersand ARR of 1. Similarly, PTR plus 2 is equivalent to ampersand ARR of 2. Depends how we are trying to access. Okay. Yeah. The thing is that we can perform any sort of movement. Either we can increment or we can even decrement if we want. So suppose if we say instead of initializing PTR with the zeroth element, I tried to initialize it with the second element. So naturally, in the memory map, let us say PTR is now pointing at the second element, 0, 1, 2, 3, and 4. Right? So if we want to access the previous, so we can say PTR minus 1, so it will point over here. PTR minus 2, it will point over here. Right? Same thing is explained over here. So we are initializing the pointer with the address of any random array element, address of any random array element, and then we are moving the PTR either forward or backward by subtracting those many blocks of memory from the